This is section 9.2 is going to be part 2. For this part, we are solving for a missing side of a right triangle using the Pythagorean theorem. And so for examples 1 and 2, I have the easier ones are examples 1 and 2, and then examples 3 and 4 I have radicals, and so we'll start working with radicals once we get to these two examples. But first, let's do the easy ones. For this ones, the first thing you want to do is identify which one is your C value, so which side is the longest side. The longest side in this picture would be the one labeled with X, so this has to be C, the hypotenuse. Another way to identify which one's the longest is just find the right angle, and then it's the side across from it. That's the hypotenuse. So that one has to be C, and then 3 and 4 are going to be A and B, and it doesn't matter which one's which. So I'm going to say 3 is A and 4 is B. And so now that I identify each of those sides, I'm going to set up my equation. So my formula for Pythagorean theorem is A squared plus B squared equals C squared. So all I'm doing is I'm replacing the letters with the numbers that I have. So my A value is 3. My B value is 4. And then my C value, that's X, is what I'm trying to find. So now I'm going to evaluate each term. So 3 squared, that's 3 times 3, that's 9. 4 squared, that's 4 times 4, that's 16, and then x squared. So there's a plus sign in between, that means I have to add them, so 9 plus 16, that gives me 25. And so one more step, I cannot have that exponent right there, I have to cancel the square, so opposite operation of the square is the square root. So the square root and the square cancel each other out. Gotta do the same thing on both sides. So the square root of 25 would be 5. I know in the past we've used square roots and we always have plus and minus. This one I only have a positive answer because I'm working with the sides of a triangle. A distance can never be negative. That's why it's only positive 5. Okay, so that's my x value. Then there's one more thing. Pythagorean triple is when all 3 sides of your triangle are positive whole numbers, and so I'm gonna write it out for this one. I'm just gonna do it right here. So A, B, and C. My A value is 3, that's a positive whole number. My B value is 4, that's a positive whole number. And then my C value, that's the one that I got, is 5. That's also a positive whole number. So then my answer would be yes, it is a triple. So in example 2, I'm going to do the same thing. Longest side is my C value, my hypotenuse. So across from the right angle, that's my C value. The other ones are A and B. So same thing, I'm going to plug it into my theorem. So my A value is X, that's what I'm trying to find. B is 16, and C is 34. So again, I'm evaluating each term. So x squared stays. 16 squared, that's 16 times 16, that's 256. 34 squared, that's 34 times 34, that's 1156. And so now I don't have x by itself yet, the x squared, so first I gotta cancel that 256. So opposite of addition is subtraction, so I'm going to subtract the 256 from both sides. So on the left side, I'm left with x squared. On the right side, 1156 minus 256 gives me 900. And so now that I have the x squared on one side of the equation, then I can take the square root, and then that'll give me my x value. So the square root of 900 is 30. So here my answer is 30. And so again, I want to know if it's a triple or not. So I check all three sides. A is the 30 that I got, so that works. It's a positive whole number. B is the 16. That's a positive whole number. And then C is 34. It's also a positive whole number. So again, my answer is yes, it is a triple. Okay, so these are really the easier two examples. This is what you practice in middle school, where you have nice whole numbers and you get whole numbers as your answer. Examples 3 and 4 is where it starts getting a little bit more difficult. Alright, here's example 3. So in here, I'm going to label again the biggest side, the longest side. It's always across from the 90-degree angle. So this is C. And then that means A and B are these ones. And same way, I'm going to set up my formula. I'm going to have A squared plus B squared equals C squared. And now I have A is x, B is the 4 square root of 2. Put that in parentheses. And then my C is 9. So same process, but now I'm having to remember how to multiply radicals. So here, 4 squared, so 4 times 4 is 16, and then times the number inside, 2. So 16 times 2, that's 36. And then 9 squared, 9 times 9, that's 81. So now subtract 36 from both sides. And so I have x squared equals 81 minus 36. That's not 36, sorry. 4 squared, that's 16, times 2, that's 32. So here I have 32. So 81 minus 32, that gives me 49. And so one more time, I'm going to take the square root on both sides, and then my answer is x equals 7. Okay, one more time. I'm going to check to see if it's a triple. So I check all three sides. A is 7, so that's a positive whole number. B, it's 4 square root of 2. Anytime you have a radical, that's not a whole number, that's a decimal. So nope, that's not a whole number. C was 9, that's a whole number. But if at least one of them is not a whole number, then it's no. This is not a triple. And then the last example is example 4. Here's my example 4. So same thing. I have to check to see which one is the longest side, and that's gonna be the 6. And this is A and B. Same thing, but this one, something different is going to happen for my answer. So my A is x, my B value is 2, and my C value is 6. That looks like a B, that's a 6. And so now I'm going to do 2 squared, that's 2 times 2, that's 4. 6 squared, that's 6 times 6, that's 36. Same thing, I have to get x squared by itself, so I'm going to subtract the 4 from both sides. And I get 32. And then gotta take the square root. And so x equals the square root of 32 doesn't give me a whole number. It's not perfect. It's a decimal. So here I cannot leave my answer like this, because if you notice, they're asking for the x value in simplest radical form. So I have to simplify this. So this is where we go back to section 9.1. In section 9.1, I had to use my list of perfect squares. And so if you remember the list of perfect squares, I'm just going to write it off to the side. My perfect squares are 1 times 1, 1, 2 times 2, 4, 3 times 3, 9. So I'm just creating my list. So it keeps going. It's infinite number of perfect squares. I have to find two numbers that multiply to give me 32, but at least one of those numbers has to be a perfect square, so it has to be from this list. And so 16 is a factor. So this is the square root of 16 times the square root of 2. 16 is perfect, square root of 16 is 4. Square root of 2 is not perfect, so it stays. And so my answer in simplest radical form is 4 square root of 2. And so this one would also not be a triple, because I end up with a side that has a radical, which means it's a decimal.